We have taken our readings for our experiment to find the resistance per centimeter of a wire by finding the potential difference across its length by changing the value of current. And our readings, if you remember, have been taken in divisions, and our ammeter and voltmeter readings are recorded in this table. Let us go along to analyze this by using the graph. We take a centimeter graph paper. Remember, the graph that we draw in physics is to relate two physical quantities which depend on each other, and therefore, the graph and the mathematics that you do for graphs can be used. Now, first and foremost, because the two physical quantities are involved in this, we should write what is the graph that we are going to plot. It is a graph that is voltage versus current. So, the heading should be always mentioned. We need not take the center of the graph paper to mark the lines. The x and the y axis can be drawn at the edges. Drawing the two axes, choosing this entire graph sheet to show our variation is absolutely a must, because it is not a number graph. So, on this axis we must write down current, and on the other voltage. Now, we need to choose a scale for the two axes. For the x axis, we can safely take from the readings 2 to 12, one division equal to 1 centimeter, and on the y axis we have to plot 6 to 35. Therefore, 2 divisions is equal to 1 centimeter. Let us mark on this x axis 2, 4, 6, 8, 10, 12, 14, and we need not mark any more because we do not have readings for that. Now, on the y axis we have 2 divisions equal to 1 centimeter. Therefore, we can put for 3 centimeters 6, for the next 3 centimeters 12, for the next 3 18, for the next 3 24, and further. Now, let us plot this 2 and 6. So, 2 and 6, our first point will be here, then 4 and 12, our next point will come here, 6 and 19. So, this is 18. So, this will be 19, 8 and 25. So, this value will come somewhere around here, and 12 and 35. Now, we have to draw a line for all these points. Remember, all the points should not be connected. It is not necessary that all of them are going to lie on the same line. What we need to do is to draw a mean line. So, 0 0 is a must, this should be included. For the rest of the points, we can see using a plastic scale such that the line that we choose to draw has points on either side, and it is a mean or average line. The advantage of making a graph is that you can then plot a line which is an average value already. So, you do not have to calculate for each value and then average it. Instead, just plot a line, average line, and that should be sufficient. So, if we draw this, this is a straight line, and we can say that for y and x, what is the relationship between them? Y is equal to mx plus c. In our case, this is the voltage, y axis is voltage, this is equal to m, and on x we have current, and our value for c is not there, there is no intercept. So, c need not be included in the equation, and so v is equal to m I is the equation of this line. The slope of the line in this case has a physical significance. What is the physical significance of this slope? M is equal to V upon I, which is our resistance. So, the resistance of the wire would come out to be the slope of this line. How do we take the slope of the line? We just draw a triangle, choosing any point on the line, a right angle triangle, so parallel to the y axis, and another base for it, which is going to be a right angle triangle like that, and the slope would be given by variation in the value for voltage upon variation in the value for current. If you were to read this value of variation, you should keep the scale in mind and what it is representing, which was not the case in a graph for math. And therefore, when you take this reading, it will be 30 minus 12, which is to show the variation in y axis, and for the other side it is 4 and this is some 9.5. So, 9.5 minus 4, and this calculation will give you approximately 3 ohms value. So, this value is the value from the graph, and you can use this to find the resistance and thereafter calculate resistance per centimeter of the wire. So, you have learnt how to plot a graph using your readings. Remember to note what the graph is all about, write the scale for the two axes, and using the scale means that you have to first study the readings that you have. The selection of the values on the x and y axis is thereafter done. Then you need to also remember that your graphical axis should use maximum paper here. You should not cut the graph, you should show a variation on as large a paper as possible. Since this is the commercial paper available, this is the best you can draw. Thereafter, plot, mark the line. If the slope needs to be calculated, you will follow as we have done just now.